Hello, everybody, and welcome to a new episode of Beam Campus. It's already June 2025, and today we will give you a little update on the status of ExESDB, the Beam native event store. So, to continue, uh, we have been focusing mostly on the observation and subscription mechanisms in this iteration, and um, observations are also known to the community as being transition subscriptions. So this means that any events that are being added to the system will be observed and published to Phoenix PubSub. Now these observations come in a number of flavors, and there are three in total. The first one is an observation by stream, and these streams can either be observing all events that entered the system, which is identified by a $all, or you can observe events for a specific stream ID, which will be identified by a $stream ID. A second flavor is the observation by event type, and as the name suggests, it will observe a particular event type for the system. So whenever, for instance, a fan activated version 1 event is added to the event store, this trigger will fire. And then the third flavor is also quite interesting. This is a filter or a trigger that allows you to filter certain events according to patterns in the payload. For instance, if you are interested in what a certain operator has done in the different greenhouses, you could add this filter. Of course, it is difficult to just create a user-friendly name for a pattern automatically. So these types of observations will require an observer name, and this name will then be used in PubSub to be the topic you can subscribe on. Yeah, okay. So that were observations. Observations are transient subscriptions. Um, so they are not really related to one specific subscriber. For that, we have introduced the subscription mechanism, and this relates to more what is known in the community as being persistent subscriptions, identified by a subscription name and usually a start from a pointer where the subscription has ended, or rather the event number of the latest acknowledged event that was processed by the subscription. So also an acknowledge event function is provided so that the subscriber can acknowledge reception of a particular event and thus update the start from pointer. As said, this subscription mechanism is intended for specific consumers or subscribers, and the emitter will forward any event to a specific subscriber ID. So far, we only support specific subscriptions by stream. We are investigating if it makes sense to have another type of filter, but so far we haven't seen many use cases for this. Please leave a comment if you can imagine one. So for now, only by stream is supported, and in the pipeline are the functionalities for replaying subscriptions, for time travel, and related to snapshots, catching up from a particular snapshot in case your event stream is voluminous. Okay, so let's go to the demo now. And for this, I will switch to a terminal window. So first of all, let's start let's start the application, right? So nice name. We start our application. There we go. And the application is now up, or at least almost up. There we are. There will be some post-started processing. The explanation for this will be provided in a later demo. Also, this might be quite interesting. Let's start the observability tool that is provided out of the box by the Erlang ecosystem. This has nothing to do with our observers and such. This is just a tool or observability tool that helps us in examining a whole lot of metrics out of the box. First of all, I've started with the tool, so let's try and put this on this screen before we continue. Here we go. All right. And let's quickly examine the ExESDB application. So there are a few points of interest here. First of all, we have the emitter pools. For an emitter pool is an emitter pool will spawn emitters for a particular subscription. And what is also maybe interesting is the streams writer. So currently we have 8 available pools for that. I have there are 8 cores in this machine, so there is a pool for each schedule, for each core in the system. Okay, that being said, so we will be observing emitter pools and we will be observing stream writers. Okay, let's continue, shall we? So the application has been started. So let's open a shell into it and start observing some things. So I have opened the shell into the running application now. ESDB.REPL start observer. And the first observer that we will start is one for all streams. So this one will really capture all the events that are being entered into the store. There we go. Let's have a look what is happening in the system. And indeed, as you can see, we have now an emitter pool for reg_gh, which is an abbreviation for regular greenhouse or regulate greenhouse, and it will emit events to the topic reg_gh $all. So that's where we will be able to get our events from. Okay, let's continue. A second observer. So let's shell into the application again, and let's start ExESDB REPL, and this time we will start an observer for a particular stream, and let's say we are particularly interested now in greenhouse 4. Okay, there we are. We start the observer, and let's switch back to our observability tool, and after a while the emitter pool for greenhouse 4 has been created. Shall we do another one? So we open we open a new remote shell into the running application. There we go. And this time we will use our REPL to start an observer for event type, and I always forget the specific event types that are available, but this gives us a nice chance to demonstrate the documentation capabilities, which are quite unique to Elixir and Erlang. So by typing H in front of the function, we can check the created documentation. And let's say we are interested in light measured events. There we go. So let's say light measured, and this is version 1. There we go. We start the observer. We check our observability tool, and indeed a light measure for version 1 emitter has been created. Okay, so far so good. Now there are a few other types or a specific observer that I would like to show you, and this is the observer that filters on a particular payload of the event. So we open a remote shell again, .REPL, start observer for event payload, and this time, as indicated in the demo or in the presentation, we will need to provide a name for this observer so that we can formulate a user-friendly or a human-readable topic. So let's call this one what Ringo did. And the pattern we want to match is operator Ringo. There we are. So let's start this observer and see what happens in the system. And as expected, an emitter pool is being created for this specific topic, what Ringo did. Okay, we're almost there, folks, so bear with me for a second, because now we will open a new remote shell into the running application and start, not an observer this time, but a subscription. Start subscription or a subscriber for a particular stream. So let's call this my sub 7. There we go. And the name of the stream will be greenhouse 7. So this subscriber will not use Phoenix PubSub, but it will be receiving events directly from the emitter. So let's start this and check if everything is happening okay in the observability tool. And indeed, there we see that there has been created a persistent subscription for my sub 7. The asterisk in front of my sub 7 indicates a persistent subscription. Okay, now we have set up all our subscribers, all well and good, but we have no events in our system yet. So for that, we will open a remote shell to the running application again, and this time we will start a number of producers. Oops, I forgot to add the REPL module. Start producers. And how many? Let's keep it simple and start 20 of these producers. There we go. So we start the producers. Let's check what is happening in the application now. And of course, now we are interested in what is happening in the stream writers branch. It will take some time before the 20 generators or the writers are created. But as you can see, they are distributed over the various pools that are responsible for them. And this also means that there will be some distribution in terms of CPU cores. So we have about 20, 2, 5, 10, that will be about 20. Will not count them. I'm more interested, honestly, in what is happening in the application. And as you can see, our producer is happily producing events for the different greenhouses. So let's now have a look at what is happening with the subscriptions. So first up, we have our specific subscription, which was watching the Greenhouse 7 stream. And as you see, we are receiving these events in the correct order in which they are created. Next, let's have a look at what the observer is doing. So we created an observer for a specific payload where the operator matched the Ringo string. And so we see that Ringo has been quite a busy fellow, playing around with humidity and temperature gauges and light gauges in various greenhouses. But this is interesting because it can have several use cases, obviously. If you can filter the events at the source, your um, your processing or your post-processing might be a little bit more easy. All right, so Ringo is happily doing stuff. Let's switch to another observer we created. And this one was particularly interested in the event type called light measured. And here we can see all the light measured events for various different greenhouses. Yeah. And now we come to the observer for greenhouse 4. And again, these are events that are being published on Phoenix Pops Up. So anywhere in your cluster, um, some process can subscribe to this and process it. The following one will be a little bit less interesting, perhaps. This is the subscriber um, that subscribes to all the events that are being created in the system. Okay, guys, this shows you the main features of the current state of the application. It might be interesting to quickly have a look at some charts that are being created by this observer tool. And this is really not very exciting, but as you can see, the load is quite distributed over different schedulers. Now, obviously, we are only creating events for 20 greenhouses, but imagine this is a very um, low low key system, uh, only 8 cores, and in a more server-like environment, the capacity for the processing would be much greater, of course. All right, guys. Then we can switch back to the presentation. So in the follow-up or in the following part, we will have a small preview of the of what is to come for ExESDB for version 0.16. So in this iteration, we will be working heavily on resilience, follow the leader principles, which means that emitter pools will follow um, the Capri or the Ra leader node. If the leader would go down, obviously we don't want our subscriptions to stop. So this is an important aspect. We will also put some attention to automated clustering of nodes. So when a node is added to the cluster, that everything is started as it should be. Something that is already available in an experimental stage is the gateway API, which we will provide as a gen server. And this will provide us with high availability for interacting with the event store. So all interactions you have seen so far from the REPL are happening via this gateway API. And so each request is distributed to a different node in the cluster. Now, obviously for the demo, I only used one node, but we are working on this, and this is coming up for the next version. Snapshots is an important thing. Um, it doesn't. Uh, it does make sense to have snapshots in any event store to have this functionality, especially if you have long, um, long-running event streams. You cannot afford to be obliged to read back all the events in order to create a state. So that's why we will introduce snapshots in the following iteration. And on popular demand, we will also start to implement and experiment with the commanded adapter. In the end, commanded is the de facto standard for event sourcing in the Elixir community. So we will certainly build a commanded adapter for ExESDB. So all that is left now for me is to thank you. Please like, share, and subscribe if you liked this video. Um, we have the project available on GitHub and on Hex. So check it out if you're interested. And if you are interested in supporting me, I'm always uh, grateful if the community supports this project, if you see any value in it. And I am open for hire. So if you are interested in an Elixir slash Erlang developer, um, please do contact me. Or if you're interested in sponsoring this project, I'm open for business. Okay, folks, this was it. Have a great day. Thank you for your attention and see you next time. Bye bye.